Imagine you're cruising at 35,000 feet, sipping coffee while hurtling through the stratosphere at 550 miles per hour. You're encased in a pressurized metal tube that defies gravity, yet you feel as stable as if you were sitting in your own living room. But have you ever stopped to wonder how this miracle actually comes to life? Most people look at an airplane and see a machine, but what if I told you it's actually a living, breathing symphony of millions of parts harvested from the deepest corners of the earth? The story of your flight doesn't start on an assembly line. It begins in remote, rugged mines and scorching refineries, months before a single rivet is hammered. We aren't just talking about steel. We are talking about a highly specific aerospace-grade aluminum alloy that has to withstand temperatures ranging from negative 60 degrees Fahrenheit to over 100 degrees on the tarmac. What happens next inside these factories is a process of such extreme precision that a single mistake, even by a hair's breadth, could mean the difference between a soaring success. Welcome to the hidden world of aerospace manufacturing. Today, we're going behind the heavy security gates of a massive aircraft final assembly line to show you exactly how thousands of raw components transform into a soaring jet. You'll see the fire, the precision robotics, and the human hands that guide it all. And trust me, when you see the final test this machine has to pass, you'll never look at your next flight the same way again. It starts with the Earth itself. The aluminum used to build the fuselage skin is refined from bauxite ore, primarily sourced from the red earth mines of Australia, Guinea, and Brazil. This ore is crushed and treated in a caustic soda solution at temperatures exceeding 200 degrees Celsius or 392 degrees Fahrenheit to isolate the alumina powder. It's an incredibly energy-intensive process that leaves a footprint you don't hear about on your airline's marketing brochure. But it isn't just aluminum. Modern jets rely heavily on carbon fiber reinforced polymers, materials that are lighter and stronger than steel. These fibers are created through a complex, secret chemical process where polyacrylonitrile precursor fibers are heated to nearly 3,000 degrees Celsius in a nitrogen-rich atmosphere. The carbon atoms align into incredibly thin, rigid crystalline filaments. This material travels thousands of miles from chemical plants in Japan and the United States to reach the wing fabrication shops. The supply chain is a logistical masterpiece that spans 6 continents and thousands of individual suppliers. A single jumbo jet is composed of over 4 million individual parts. Think about that for a second. If you lost one single nut or bolt during the transit of these parts, the entire assembly could come to a screeching halt. But here is a secret most people never realize. The parts are often produced in countries thousands of miles apart and only meet for the first time on a factory floor, yet they fit together with a tolerance of less than a millimeter. The scale is truly staggering. By the time the raw materials arrive at the assembly plant, they have been vetted by rigorous, independent international inspectors. If a batch of alloy doesn't meet the 99.9% purity threshold, it's rejected, no questions asked. But the real mystery isn't just how they get the parts there, it's how they force these rigid, heavy components to curve into the sleek shape of an airplane wing without snapping. Now, we enter the heart of the beast, the final assembly line. The fuselage sections arrive like giant hollow barrels. The first phase is a riveting process. Millions of titanium fasteners are installed under immense pressure. Using specialized pneumatic tools that deliver 90 psi of air, workers, often assisted by robotic arms, drive these rivets home. The sound is deafening, a rhythmic, percussive roar that vibrates through your chest, a constant reminder of the raw power being tamed. Once the skeleton is set, the internal nervous system begins to snake through the airframe. We're talking about over 150 miles of wiring and hydraulic tubing in a single wide-body jet. These lines operate at hydraulic pressures of 3,000 psi to control everything from the landing gear deployment to the flight surfaces on the wings. If you were to touch these pipes while they are active, the pressure will be enough to pierce through heavy-duty gloves. The wings, the most complex aerodynamic structures on Earth, are attached next. Because they need to flex under the stress of heavy turbulence, they aren't bolted in a static way. They are engineered to bend up to 20 feet upward during extreme stress tests. The assembly team uses laser alignment systems that beam light down to the micron to ensure the wing-to-body joint is perfect. 1 degree of error here, and the plane would veer off course the moment it left the runway. Next comes a propulsion system, the jet engines. These marvels are built in completely different, highly specialized facilities. They have to withstand temperatures of 1,700 degrees Celsius inside the combustion chamber. That's hot enough to melt most metals, which is why the turbine blades are made from advanced single-crystal superalloys. The assembly of these engines is so delicate that it's done in a white-glove, clean-room environment. And what happens when they finally bolt that engine to the wing? The shift in the plane's center of gravity is so precise, it's practically invisible to the human eye. Quality control is where the human element becomes non-negotiable. While AI-driven vision systems and high-speed cameras scan every square inch of the fuselage for microscopic cracks or surface inconsistencies at a speed of 10 meters per second, the final sign-off is human. Machines can detect a flaw in the metal, but they can't interpret the subtle nuances of fit and finish that define a premium build. We subject these planes to stress-to-failure tests that would terrify the average person. In the testing lab, they take a full-scale wing and pull it upward with hydraulic jacks until it snaps. They need to see exactly at what point the structure gives way, which is always far beyond the stress of a violent thunderstorm or a hard landing. The rejection rate for a primary structural component is nearly zero, but when it does happen, it costs the company millions of dollars in wasted time and materials. There is one moment that stands out during the final inspection, the swing test. It's when the landing gear is tested to ensure it can deploy in under 5 seconds under gravity and hydraulic pressure. If it takes even a fraction of a second longer, the plane is grounded. It's a nerve-wracking process that makes even the most seasoned engineers sweat. And yet, this test is performed perfectly thousands of times a year. The global manufacturing footprint of aviation is massive. Every year, thousands of commercial aircraft roll off assembly lines across the United States, Europe, and increasingly, Asia. The industry supports over 10 million jobs worldwide, from the mine workers in Australia to the software engineers in Seattle and the aerospace technicians in Toulouse. It's an industry worth well over $700 billion annually. 50 years ago, we were building planes with slide rules and paper blueprints. Today, we're using digital twins, virtual replicas of the plane that exists in the cloud before the first piece of metal is cut. These digital twins allow engineers to simulate 10,000 flights, crashes, and weather scenarios before the physical plane is even assembled. It's a reason that flying is safer today than it has ever been in human history. Did you know that the total distance a plane travels in its lifetime could reach millions of miles? Or that the paint on a Boeing 747 weighs as much as 1,000 pounds? And here's one that surprises even the experts. If you stripped a modern jet down to its bare frame, it would actually be light enough that a heavy truck could pull it across a runway. It is a sophisticated engineering of the aerodynamics and the engines that makes the impossible feel. We've traveled from the red dust mines of the southern hemisphere to the laser-guided clean rooms of the north, witnessing how raw becomes a machine that conquers the sky. It is a journey of heat, pressure, and human ambition. Every time you board that plane, you aren't just sitting in a seat. You're sitting inside the pinnacle of human collaborative achievement. The next time you hold one of these in your hands, remember, it didn't just appear. It was born from the earth, shaped by fire, perfected by technology, and approved by the strictest standards in the world. That's not just a product. That's a masterpiece of human engineering. If you want to go deeper into the hidden world of manufacturing, tell us in the comments what product you'd like to explore next. Like this video, subscribe to the channel, and